Good morning.
So now, let us see the graphical representation of a simple harmonic motion. So that is only we can say is a simple pendulum and how it will be making. So I'm going to introduce a concept called it as periodic motion of particles. So if it is very, very small, like displacement, so then like we can say is, if the body is displacing to and from motion along a straight line, then that is what we used to call it as SHM actually, simple harmonic motion. So actually this SHM is entire class 11 oscillations, chapter number 13 oscillations. We are going to study again the periodic motion. And in that periodic motion, only we are going to talk about SHM, simple harmonic motion. So of course, that is only we are going to make now. So you all knows already I have taught you if you have been taken two things. Let us revise now. One is time period. So you might be all remember the time period. Can anybody define what do you mean by time period? Time period means what? Time taken to complete.
One oscillation.
Yeah. Time taken to complete one oscillation or one vibration, which we used to call it as time period. And then next one is amplitude. So what do you mean by amplitude, everybody? The maximum displacement from which point? Everybody. Maximum displacement from, yes, please respond, mean position. So of a particle, that is only ways to call it as displacement. Is it right, guys? Please respond. All of you? Yes, please. So now, let us take periodic motion of a particle. So all of you keep heading. Periodic motion of particles. So what do you mean by periodic motion? You all knows that. Can you tell me what do you mean by periodic motion? Class 8 you studied, 9th class also. At the starting types of motions I have taught you. So what do you mean by periodic motion? Sanjay? Periodic motion means, for example, if you take the earth around the sun, so earth around the sun is in a periodic motion. So after every 365 days, what will happen? After every 365 days, what will happen? Everybody.
Same
Earth will
position.
start revolving again. Same. Repeating of the same action after interval of time. You all might be knows. Your home you might be having a wall clock. So wall clock, the pendulum will be there. The pendulum, you can notice it. It will be keep on repeating the same oscillation again and again after equal interval of time. Am I right, everybody? I want to answer, please. Yes, all of you?
Yes, sir.
That is what. So, what do you mean by periodic motion of a particle, everybody? So, if you take the movement of hands of a clock, suppose if you take after every 1 minute, three hands will be there. One is minutes hands, one is hours hands, another one is
Okay.
seconds hands. So, every particular time period, the hands, the hands of a clock will be keep on repeating. Minutes hand, every 1 minute, that's what seconds hand. Seconds hands, every 1 minute, it will repeat the same path. Hours hand, every 12 hours, the same path. Minutes hands, that's what we can say. Every minute it will be take, every 1 hour, the path will be same. So that is what you can take hours hand or minutes hands or seconds, whatever it is. They're repeating their same path after a equal interval of time. Am I right, everybody? After a regular interval of time, they will repeat itself at a interval of time. That is what we used to call it as a to and fro motion, such as we can take, like, for example, a swinging pendulum. A swinging pendulum to and fro motion, which is like we can say vertical oscillations, or you can take, like, for example, so there is a spring. So there is a spring and I attached a mass. So now if I stretch it and if I leave it, so if there is no air friction, so what will happen? The mass will come down and again it will be go up. Mass will come down and go up. It will be keep on oscillating. Am I right, guys? Everybody, vertical oscillations of a mass. Am I
Yes,
right?
sir.
Please respond. So that is what we used to call it as. That is what this repeating, repeating a swinging of a pendulum or the vertical oscillations of a mass which is suspended, or if you take, if there is,
Repetition of
yes, no,
oscillations.
yeah, if there is, see, these and all, a sun revolving around the earth, the hands of a clock repeating after, this all are called it as periodic motion. Now, in this periodic motion, if it is making to and fro motion, to and fro motion. What do you mean by to and fro? Back and forth continuously. That is what, if suppose if there is a pendulum, if I disturb it, there is no air friction. What will happen? That pendulum will be keep on oscillating to and fro motion. Am I right? Please speak, guys. All of you?
Yes.
Yes. So that is what we used to call it as SHM, simple harmonic motion, a straight line motion. It is not too much. For example, if there is a pendulum, now let me consider some X. So that boy has been taken to this point and he disturbed it. Now you tell me, it will be keep on, it will come. This is the what point? Extreme point. And this is the what point we used to say is mean
Main
position.
position.
If we release it, what will happen? The bob will go from extreme point to mean point, and again the same this side also it will comes to the same extreme point. And if there is no air friction, it will be keep on oscillating. So again it will comes to the initial position. Initial position, we can say how many oscillations? One vibration or one oscillation. Am I right or wrong? Everybody speak, guys. Yes, that is.
Yes, sir.
Now, if you notice it here, this is call it as, if there is no air friction, this motion is keep on repeating. This is call it as periodic motion. But if you see, it is not a straight line. It is a curved path. If it is making a curved path, it does not. If it is displacing more, see that it is making angle is very high. Let me take angle is theta. Is it right or wrong? If the angle theta, angle is greater, angle is greater, it is not a SHM. It is the periodic motion. What is it motion? It is the
Periodic.
periodic motion. So, SHM means the harmonic motion in which amplitude and time period of oscillation remains constant. Amplitude and time period remains, what will happen, everybody? Remains constant. And the theta must be, theta refers to be extremely small, very, 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 very small. Then that is the motion of a particle which we used to call it as, it is refers to a what, everybody? It is refers to SHM, simple harmonic motion, SHM. So in SHM, the acceleration of the body or the particle executing the motion which is directly proportional to the displacement, directly proportional to the displacement from its mean position. And always remember, now I will get the answer from you yourself. Now let me take Mr. Kishore or somebody X has been taken the bob to this point. Now the bob is displaced to extreme point, displacement X. Now you tell me, if he release the bob, wherever the bob, either this point or this point, the acceleration is towards to the mean position or towards to the extreme position. That is what I wanted. Body will start accelerating to which point? Anybody?
Towards the main.
Towards to the mean position. That is very important, because when it will coming to the mean position, the velocity increases or decreases? Velocity increases.
Decrease.
Understand? Increases. Again from mean to extreme, decreases. Again from extreme to mean, increases. Again from
Decreases.
mean to extreme, decreases. Am I right or
Decreases.
wrong? Because when the bob is reaches to the extreme position, velocity becomes what? When the bob is reaches to the extreme position, velocity becomes what? Everybody.
0.
Velocity becomes 0. So where velocity is maximum? Velocity is maximum where? At mean position. Do you all understand? Everybody, please. Anybody having any doubt? Let me know. Are you clear, everyone? Yes, please. So the
Yes, sir.
bob is accelerating. The bob is accelerating towards the what point? Everybody. Yes, please. Bob is
Yes,
accelerating
sir.
towards the main position. That is what? The motion is directly proportional to its displacement from the main position, and it is directed towards the main position. So, in this case, if there is no air friction, always the total mechanical energy of the bob is remains what? Energy neither be destroyed nor be created. So the total mechanical energy of a particle is remains what? Energy of the particle is remains. Yes, please. Nobody can create, nobody can destroy. So energy can never near always remains what? Remains conserved. So that is what we used to say is periodic motion of a particles. So here I am introducing a concept, call it as SHM. So what is SHM, everybody? The amplitude and time period remains constant. Understanding? So harmonic motion in which where the amplitude and time period of oscillation remains constant is particularly referred to as SHM. So please note it. SHM means A amplitude and time period remains constant, and the theta must be what? Small or large? Theta must be small. Okay. So for example, so there is a bob. Now, imagine this is the main position and some X person has been taken the bob to here and he released it. So the bob will go to main position. Again, this side also it will comes to the another position. Again, it will go back. Again, it will come back. Again, it will go back. Have you noticed that? It is almost a straight line. Am I right? Is it a path, curved path or a straight line? Everybody. Straight line where theta is very, very small or large. Theta is very, very, then theta is small. This is called it as SHM, simple harmonic motion. Sanjay, okay, Sanjay?
This pendulum is one of the example of SHM.
Yes, anything, Mari. You can take like vibrating string, vertically vibrating spring. That is also simple pendulum. To and from motion. To and from motion. It's
Yes, sir.
not too much. Remains amplitude and time period remains constant. That is you have to remember. Clear?
Yes, sir. That means
Yeah. Tell me. So now, let us draw the graphical representation of SHM, okay? And how that characteristics and how this relation will be, let us see that, okay? So now if I take the pendulum, so we all knows that. So I am drawing the mean position. So mean position, solid line. So if I take any point, so let me take a small angle. So that is what A point. So A point, what we used to call everybody? Extreme position. Am I right? Yes or no, guys? And same way, it is comes to the main position and opposite side also another point will be there. So what is that point? Another extreme point. That is point B. So mean point, extreme position, whatever. So now, what will happen? The pendulum oscillates to and fro motion. When the time taken to complete one oscillation, what we used to call? Time taken to complete one oscillation. Time taken to complete one oscillation is called it as time period. Okay. So that is what. So we all knows, you all people knows time period means, sorry, one wave. Time taken to complete one wave means one crust and followed by one trough. Sir, how to draw it now? So let us see that. So if I plot SHM graph, displacement versus time amplitude, displacement versus amplitude, you can see this. So A and B, we used to call it as extreme position, and O is call it as a what? Everybody. O is call it as, speak guys. O is call it as main position. A and B is call it as a what? Sanjay, Sam, speaking of extreme
Extreme
positions.
position.
sir.
So now,
Yes, sir.
Yes, Mari.
Sir, is this pendulum as a SHM?
Yeah, simple pendulum, SHM. Okay. Clear, Mari? You can take any object, Mari. For example, you are having, have you noticed, for example, you see something is hanging in our, imagine a ring. If you hang it to a screw or somewhere, like that is what we used to call it as pivoted. Pivoted. Do you understand? Pivoted means fixed point. Understanding? Huh? So now, suppose a wind blows. If this ring is oscillated, suppose imagine for a wall you fixed this one, some object. If wind blows or if you give a small push, so this object will be start moving a very small displacement. Then that is also called it as, this is called it as physical pendulum. Physical pendulum. That is also in SHM only. Do you understand that? Clear, Amari? This is
Yes,
physical
sir.
pendulum. This is also we can say which is SHM only. Clear?
Yes, sir.
Yes. So this is simple pendulum. And if you take, for example, there is a ruler, scale, you all know, correct? Scale, there will be, imagine one point is pivoted. One point is pivoted. Now, if you have just given a small push, so that the scale is just vibrating to and from motion. Small, from its mean, from the axis of rotation, or a small displacement. Then that is also called it as, that is physical pendulum. We used to call it as SHM. So physical pendulum means any rigid body, any structure. So if it is making a small displacement, that is what to and from motion from its mean position about an axis of rotation, that is what pivoted point. So then that is called it as physical pendulum. So for that also we used to say SHM only. So of course, you are going to calculate time period for this one and time period for this one also. Okay, Mari? Clear? Everybody? Yes, please respond. That is what.
Sir.
Now, if I draw, let me take simple pendulum. Of course, this physical pendulum and all we will study in 11th. Don't worry that. So now coming to the simple pendulum. The simple pendulum oscillates to and from motion. And the time taken to complete one complete oscillation, one complete to and from motion is called it as a what? Everybody. Time period. Is it right or wrong? Yes, please. And when the bob is at either at point A or when the bob is at either at point B, either point A or point B, that is called it as at point A or point B. We used to say is maximum displacement. So if it is the maximum displacement, we used to call something. What we used to call? Everybody. If it is maximum displacement, then what we used to say is everybody maximum displacement from mean position. From its mean position. What we used to call it, guys? Maximum displacement from its mean position. We used to call something. I want answer, please. Everybody. Which we used to call it as? Amplitude. I am not asking anything new. Which is call it as amplitude. So, if I draw the graph, displacement versus amplitude. Okay. So, plus A and down what will be there? Plus A, down what will be there, guys? Minus A. And I am putting O. So actually what is this O means? Mean position. So this upward displacement, positive, downwards, negative. So now, first, wave is at, initially the bob is at mean position. Okay, mean position. So now I have taken to extreme position, extreme A point. So A point means the bob is at here. I have displaced it to A point first. So A point maximum displacement or minimum displacement? Everybody. Yes, please respond. Maximum displacement. So see that from A to O to B, again from, see all of you observe, A to O to B, again B to O, and again O to A. Then that is totally we used to call it as a what? One oscillation, and the time taken to that what we used to call, speak loudly. Time taken to that, call it as? Time period. Time period. It's okay, wa? Now, bob is at A point. Bob is at A point means energy is what? Maximum displacement or minimum displacement? Maximum displacement. Now, if the total time is T means, now if I release the bob at A point, so what is the time taken to reach to the mean position? Anybody can tell? What is the time taken to reach to the mean position? All of you. Yes, please. Mean position means again it reaches to here. So can you tell me what is the by the time period? Anybody? T by 2. Okay. And again B to A after it is reaches to there. So by the time, what is the time period? Anybody? See, maximum when it is.
Sir, but when it comes to the mean position, that is
Yes.
O,
Oh,
the
oh,
T
oh.
decreases, no, sir.
Mari, time I am saying, Mari, total time is T. Going and coming
Yes.
back. Going and coming back is T. So now A to O, what will happen? A to O, it will become what? T by 4. And again, here this one, T by 4. And again, T by 4. And again, T by 4. Totally T by 4 plus T by 4 plus T by 4 plus T by 4, which is equals to T. Is it right? That is only call it as time period. Am I right?
Yes, sir.
You understand?
Yes, sir.
Yes? Please respond.
Yes, sir.
Yes. So what will happen now? A to O, T by 4. A to O. A to O, what will happen? T by 4. So means first O to A. O to A, T by 4. A to O again T by 4. And next, see, imagine it is starting from O point. O to A, T by 4. So this is the point where time period is T by 4. And again, O to A, sorry, A to O, again T by 4. So T by 4 plus T by 4, how much time period? T by 4 plus T by 4, how much? T by 4. T by 4 plus T by 4, how much, guys? 2T by 4, which is equals to T by 2. Is it right or wrong? Please respond.
Yes.
Yes. Now, again it is going to O to B. O to B means again T by 2 added. So T by 2 plus T by 4. How much it is, everybody? T by 4. T by 2 plus T by 4. Again you adding T by 4 plus T by 4 plus T by 4. How much, Ra? 3T by 4. So when it is become 3T by 4, Bob is at what point? Bob is at what point? B point. So that when the Bob is at B point, what is the time period, everybody? When the Bob is at B point, what is the time period? 3T by 4. And again, when the time become T by 4 again, 3T by 4 plus T by 4. What is the time period? Which is equals to how much, guys? 4T by 4. So 4 will get cancelled. T will become what? T. So means Bob is at what point? Anybody? Started from O and again came back to O. So by the time of T, Bob is at what point? Mean position or extreme position or?
Main position.
Mean position. Okay, va? Do you understand, Ra? Everyone, please respond, guys. All of you?
Yes.
Clear? Everyone?
Yes, sir.
Yeah. Ma, listen always. One wave means it can start from mean position. This is the starting point. You can take it. It will go to extreme position, T by 4. Again, it will come back, T by 4. Again, it will go to the B point, T by 4. Again, it will comes to the O, T by 4. Then we can say what? One oscillation. Am I right or wrong, everybody?
Yes, sir.
Please respond, all of you. So one oscillation means going and coming back to the same initial point. That is what we used to call it as one oscillation. Is it okay, guys? Everybody? Yes?
Yes, sir.
Now, second oscillation. So now again second oscillation, it will go to O to A. Now tell me what is the time period. Again T by 4 you add it. So T plus T by 4. How much, Ra? T plus T by 4. How much? T plus T by 4.
20 by
5T by 4. Am I right? Speak, everybody.
Yes, sir.
5T by 4. And again it will come to the mean position. So what point it is? Anybody? By that time. Again 1 T by 4 you add it. How much it is? 6T by 4. Is it right? And again another T by 4. It will go to the extreme point. So what is that point? Anybody? What is the time period? Nobody has. 7T by 4. And again, after T by 4, it will comes to the mean position. So what is the by the time period? Anybody? 7T by 4 plus T by 4, which is equals to
80 by 4.
8T by 4. 8T by 4 means how much, Amma? 2 ones are 2 twos are, which is equals to how much, guys?
2T.
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 Understand now? Shivani, clear? Mari, any doubt? Please let me know. Agalya, late. That's what. So this is what simple harmonic motion. So simple harmonic motion, the graphical representation of a simple SHM, and if you take the time periods, this is what we used to say. So please remember, the time taken to complete one oscillation is called it as time period. And when after every t/4 seconds, you have noticed that initially if you consider mean position is my initial point, so the time taken to go from initial point to any extreme point is t/4. Then extreme point to initial point, again t/4. Again from initial to another extreme point, t/4. And again extreme to initial point, again t/4. Then only we can say how many oscillations?
One
Only we
oscillation.
can say is one oscillation. Understand, everybody? I want answer from everybody. Is clear, everybody? Mr. Mukesh, Nivedan? Entire 11th class, we are going to work about only this section. That's the reason I'm saying you. Anyone having any doubt, you can ask me, or else we'll proceed further. Is it okay, guys? Yes, please.
Yes, sir.
Yeah. So please make it. Okay, now. So now before I have told you nodes and antinodes, but many of you are not clear. Am I right, Mr. Sanjay, Mari, everybody? So now let us finish.
Trust and
Yes, yes.
trust.
So let us make it into nodes and antinodes. So when it will be happening, only reflection of time will take it. So that is what actually it is. Progressive and stationary waves will take it. So when we can say, for example, so imagine there is a hard surface. There is a hard surface. So there is a mean position like a rope. So the wave is started from P point and it is going and going and going and it is strike at the point. Let me take that point is Q. So this is the wave which is going from a certain point. Now, after hitting this hard surface, what will happen, everybody? So this is what we used to say is a progressive wave. What is the wave we used to call it as? All of you? We used to call it as progressive wave. A wave, sound wave, or whatever it is, call it as progressive wave. So remember, progressive wave means some waves starts at the point of origin of the waves and progress endlessly into another part of the medium. That is the waves which we used to call it as progressive waves. Now, imagine the progressive wave is like we can take a transverse wave or that transverse water wave moving from one point to another point. Suppose if you disturb the water surface, we all know. So the waves will started moving from one point to another point. Am I right or wrong? I already told you. On the surface of water, what waves will be produced? Transverse wave or longitudinal waves? Transverse wave. And inside the water? What will wave?
Longitudinal waves.
Yes. So inside water, it is a longitudinal. If I disturb, suppose if I throw a stone on the water, what will happen? You might be noticing. Waves appears to be like a concentric circles. Am I right?
Yes.
How many of you experience it? But does it, they are a transverse, they are the concentric circles or they are the transverse waves? Particles are rising and falling. You can notice it. So what is that waves actually?
Transverse.
They are the transverse waves. So that is what is called it as actually a progressive wave. So if you take, it is moving from point P to point Q. Now, after it is, imagine like tank, like it is hitting the wall. The wave, I drop a stone, it is producing a transverse wave and the wave is keep on progressing, moving. And finally it is hit the hard surface. So like it may imagine the point is Q. So if you notice it, so this is the wave which we used to call it as incident wave. What is the wave we used to call it as? All of you? Incident wave. Clear? Now, once it is hitting the hard surface, so what will happen? We all know sound if it is hitting like a light. If it is hitting the hard surface, it has to be what? After hitting the hard surfaces, what will happen? It will be reflect back. So, it then gets reflected at point Q and again it will travel towards to the point P. It will travel towards the point P. It will be traveling towards to the point P. That is the wave which we used to call it as stationary wave. What is the wave which we used to call it as? Everybody? Yes, please. Stationary wave. So they're going from Q to P. They're going from Q to P, and the reflected wave overlapping. Have you noticed that? It is overlapping the incident wave. Am I right or wrong? Please respond. Incident wave is going P to Q. P to Q is incident wave. And reflected wave is coming from where to where? Everybody. Q to P. So both are overlapping. So it will be resulting in the formation of, because of this reflecting, overlapping incident ray and reflected ray, it is resulting in the formation of two things. One is nodes and another one is what? Another one is what, guys? Please respond.
Antinodes.
Antinodes. So now you should understand. When I'm teaching the numerical, just I told you nodes and antinodes. Now you understand what is nodes and antinodes. I will say you. So what will happen? When any incident wave is moving towards from its hard surface, after hitting the hard surface, the reflected wave will overlap the incident wave, and then it will lead to the points which we used to call it as nodes and antinodes. So what is nodes? So the points where the displacement of a vibrating particle of the medium is zero. Where the displacement is zero, anybody can tell me? Where the displacement is zero? This is the displacement zero. Is it right or wrong? I want answer, please. And this is the displacement zero. Am I right or wrong? That is what we used to call it as nodes. What is to call? Where the displacement is zero, that is call it as node. My incident ray means what is the sound we are producing. That is called it as the wave disturbance. If you put a stone, at that point the wave will produce. Then from there it will move towards to the surface. Then if once it will strike the surface, then from that point it will be coming back. Do you understand, Laksha? That is only. Clear? Understand, Amare? So where the displacement of a vibrating particle of the medium is zero or minimum. Zero. Displacement is zero or minimum. Then minimum, that is the point which we used to call it as, what is to say, everybody? Nodes. So please remember. Now, and the points where the displacement of the vibrating particle is maximum. Where is the maximum? Everybody? That is the point. Where it is the maximum displacement. That is the point which we used to call it as. What is to call? Everybody? Please put antinodes. So antinodes which to say. So
So
no,
one doubt, sir. Is
Yeah.
this called as stationary waves?
yeah, when it is reflected and overlapping the incident wave, then that is called it as stationary wave. Clear?
So then which is known as progressive waves, sir.
The wave which is moving from the initial point and moving towards to that continuously, that is called it as stationary. Only incident wave is called it as progressive wave. Clear?
Sir.
Understand?
Yes, sir.
Yeah. So the wave which is overlapping the incident wave, then that is called it as stationary waves. Okay? Yes?
Yes.
Yeah. And these closed figures, incident wave and stationary wave, closed figures, they are called it as loops. What is to call? Once it will form closed, you can see closed, they are called it as loops. So how many loops are there in this figure? Anybody can tell? In this figure, how many loops are there?
3.
3 loops. So in this figure, 3 loops are there. So the closed figures so formed are called loops. So this is what you have to remember. Okay, everybody? All of you clear?
Yes, sir.
Sir,
Yeah.
the anti nodes is available in the bottom trough also.
Yeah, anywhere, bottom also. Anywhere, maximum displacement. Okay?
Yes, sir.
Yeah. Clear, everybody? All of you